Okay, guys. All right, so we should be recording now. Welcome back to second week of the spring 2021 semester, and we're going to continue talking about our database stuff. There's something that I want to go over. A couple of people have messaged me with some questions regarding the how to get everything set up with the the Apache stuff and all of that. So let me go ahead and I'm going to share. Let me see which how I want to do this. I guess I can do it this way. Yeah, I'll do it this way. I'll do, because I'm going to be working with a couple of different things. I'm going to share the screen. I'm going to share the whole screen number 2 there. Okay. So so what you should see here is, okay, so this is 2 separate programs I'm going to be showing you. And what I've done is I've downloaded and installed Schema, this Apache, MySQL, PHP, and Perl utility. And so if we come over here and look at, I'm going to switch back over to the internet browser here first. So if I try to pull up localhost PHP myadmin right now, so if I try to load this right now, it should give me an error. Yeah, site can't be reached. It doesn't know what this whole localhost thing is. It's, I don't know what that is. So in web development, localhost is basically when you have your machine that you're currently on acting as a web server, that localhost becomes whatever the web server is. So you don't have to use a specified IP address. It's also, if you've ever seen any memes related to this, the 127.0.0.1, that's home. That's just basically the current local thing. So I can't reach that right now because I am not running this as a web server at this point. That's where this fun Champ utility comes in, is I can start the Apache service, which basically says, okay, I want this computer to act like a web server now. Okay, so what should happen is I should be able to get to something. So yeah, so now if I go to localhost, notice localhost and this are both the same thing, right? Okay, they're both exactly the same page. This one's bigger only because because it's at not 100%. It's at 100, more than 100%. So if I switch that down to 100%, these are the exact same thing. So localhost 127.0.0.1 are the same thing. Okay. So for making things simple, I am just going to use the localhost version. Okay. But now what I really want to do is I want to use this as a tool to do MySQL stuff. So if I start the MySQL service, okay, so now we have the Apache service running the localhost. The MySQL service will allow this to be able to be used as a database utility. Okay, so here, the localhost PHP myadmin, these are all of my databases. When I started this thing, when I ran this, okay, these 4 here existed. This is an old one I created last year as an example for this course. I haven't looked at it in a while, so I actually don't even know what's in there. And I think the word vaccine is spelled wrong. Okay. Anyway, the point is that if you want to create a new database, you can just click on this new button here, and this will show you the databases that you have. And what I can do, excuse me, is I can create a database using a specific name. So in this example here, the CSE 204-2021, I just typed that in. I used the UTF-8 configuration. I don't know. I honestly don't know the collation. Rather, I don't know the difference between the different formats there. Some of you might know more about that than I would, but I just decided to go with what what seemed to be pretty common here. UTF-8 general CI is under a lot of these. All right, what you choose, I don't know if it matters. That maybe that some of them allow for certain types of characters more easily, like Turkish characters, for example. But honestly, I don't know the difference, and so so just go with whatever. Now, when you create that database, you click the create. You're going to get this where there's no tables found. There's no tables in the database. What we can do is we can create a table. So I may say something call it my table. Let's just give it 4 columns. All right. You can give each column a name. So you could say column 1. Actually, let's give it a real name. Columns never, you shouldn't, they're just like variables. You should not name them weird meaningless names like column 1, column 2, because then they don't really mean anything. So let's say we're going to create an example table of movies. You know, we had the movie database, right? The IMDb. So we could have something like a title of the movie. Now, somebody had a comment. You're suggesting something. Okay, thank you. Right, so the title should be a string, as Sorana is, I believe you're suggesting for this. Now, the cool thing, though, about the MySQL and a lot of database utilities out there is you see there's lots of different numeric types, date types. There's different string types. We'll get into what all these different, what some of these different string types mean. Char, what's the difference between char, varchar, and some of these other things as well. Blob, what is that? We'll get into that later. For now, I'll just call it varchar because that's what's most commonly used. And see a title, make it 50, which basically we're saying how long of a field do we want to allow this to be. So title, it might have what maybe a runtime in minutes, which we could say that's an integer, right? Because the number of minutes is going to be some integer value most likely. We could have maybe a director, which would also be a string in this case, because we're gonna later you'll see why it wouldn't be that, but that would represent the person's name. That probably be okay to make it 25 characters. And then what else besides the title? What else does a movie have? Genre, maybe. Okay, this is just some examples, right? Category, I think that's genre too. I think genre is another word for that. So a genre, maybe something like 10 characters, like horror or action. Science fiction, that's maybe 15 characters. Science fiction is a longer word. Anyway, so now what you can do is before you create a table, you can click this preview SQL button, and we'll get into some SQL today, right? And it'll show you what the SQL that we would run in order to create this table, okay? Next week, we'll talk about the create table. Next week, maybe the week after, we'll talk about the create table SQL of this. But the nice thing about MySQL is it allows you to not only have this cool user interface to be able to do the SQL for you, that you don't have to write the SQL yourself, but also you can preview it so you can see what it looks like, and you can know what's going to happen when you click the save button. So, all right, so we're going to save. It runs that SQL and it creates, well, okay, and it creates this table. All right. And now you notice it has these columns, name and what type and all this, but this is the structure of the table. If I wanted to browse, which is the data of the table, I've got no rows in my table. I've got nothing down over here, right? So what I can do is I can add some values. So I might say Star Wars might be a title. Star Wars, how many minutes is that? I'm gonna make something up. 150. George Lucas, I believe. Genre science. And then maybe Avengers. As long as we're going Avengers, I mean that's like a super long movie, isn't it? It's like 3 hours or something. Who's the director of that? I don't remember who the director is. Genre, we'll call it action. Okay, so we can go. Now you don't have to fill out both of these, but it's just basically a quick way to be able to add some data through the user interface value. Now notice again, we get this SQL that we see happens. That's what's going on behind the scenes. That's something we didn't do. We didn't write those SQL statement directly. You will learn in this class how to do that, how to write this SQL, because what you're going to find is in a lot of situations, writing an SQL statement yourself is a lot faster than even doing that user interface thing that we just did. Okay, but now if I go back to browse and I see this there, now I have my 2 rows that I just put in there. Okay, so the reason why I'm showing you this, how to kind of get a little intro into how to use the MySQL, is what I would suggest you start doing is go ahead and make a sample database, create some tables, start putting some data in there through the user interface, and just see how it kind of structures itself in this spreadsheet style format, and how you can see the different data and across different tables. Because when we start writing our SQL statements, when I start teaching you how to write those SQL statements, I would like you to be able to have some sample data that you can practice on. Okay, so that you're not then trying to create all this sample data then, but go ahead and start putting some stuff in there now. All right. Okay, so that was kind of that intro and how to do that. Let's go ahead and get on into the relational model here. And if you still have any more questions about how to get that Apache MySQL stuff set up, go ahead and message me. I want to make sure that you guys have something available to you to be able to practice with. Oh, one other thing. Some of you have messaged me asking, can you use SQL Server? Can you use there was a couple of other ones that you had asked about. And I say again, just like I said last week, yes, you can use any database utility that you want. If you have access to an Oracle license and you want to use that, great. If you have access to Microsoft Access on a Windows computer, great, use that. If you want to download and install one of these Apache MySQL utilities and get that up and going, great. That's what I'll be using for the in-class examples. So you'll be the most able to follow along in that way. But I do want to remind you that the class notes, the assignments, the exams, the quizzes, they'll all be based on what we do in class. So they'll all be based on what the course material teaches us. There are some minor differences between some of the different database utilities in terms of how they do things. And so, yeah, so you may need to learn both ways is what I'm getting at with that. Okay. All right. One thing that I don't know if I did last week or not, I don't know if I introduced with a quote of the day. I love doing quote of the day. So Clifford Stoll tells us that data is not information. Information is not knowledge. Knowledge is not understanding. Understanding is not wisdom. And basically what this is getting at is it's one thing to understand or to know a piece of data or a piece of information, but it's another thing to understand its meaning, right? And so, there's another old saying that they say that knowledge is knowing that a tomato is a fruit. Wisdom is knowing not to put it in a fruit salad. If you know what a fruit salad is, kind of a mixture of different fruits like apples, bananas, strawberries, stuff like that. And most people would not want you to put a tomato in that, right? So this is an interesting quote that I thought was neat in light of us talking about lots of data, right? So hopefully not only in my class do you gain a little bit of knowledge about how to operate a database, but you gain some understanding as well. And ultimately, what I'd like for us all to be able to come out of the end of this next semester with is a little bit more wisdom than we had before. Okay. All right. So today we're going to talk about the relational model, right? And we're going to talk, it's kind of a bird's eye view. It's kind of a big picture type thing of what we're going to be discussing throughout this next semester. Okay, so we'll talk a little bit about some terminology, some of the properties of the database relations, and some of the purposes and advantages of views that we'll talk about some of that as well. All right. Okay, so you're going to hear us talk about two things. You're going to hear us use two words pretty frequently. One is relation, another is relationship. Now, those are not the same thing. A relation and a relationship are not the same thing. Okay, I want to make sure you know that. A relation is a table. So if you think of it as in terms of similar to an Excel spreadsheet, the relation would be the sheet. So you know how on an Excel spreadsheet or on a Google sheet, you can have multiple sheets, right? You can have multiple tabs on the same Excel file. Well, if you think of it, each tab is kind of like its own set of data, is its own table, its own set of columns and rows, all right? So a relation is like that tab. It's a single set of columns and rows, okay? An attribute is the named column of the relation. So we'll have for each column, right? For each column is an attribute of the relation. Now, again, we've talked before about how in a lot of ways a table is kind of like an object or a class in Java, right? So an attribute would be like the property, the variable. We also call them attributes in that course as well. So in the same way, it's like if you think of each row as being an object, right? Then, and the table is like a class. So the table is telling you how the object is put together. The row is an actual instance of the object. And the attribute is that column. The attribute is that specific value, right? Or something that tells you that type of value. Okay. Now, one thing that we didn't get to do a lot of in Java, as far as the attributes were concerned, is we didn't get to put a lot of restrictions on what they could be, right? The set of allowable values, at least not easily, right? You couldn't just click on something and say, oh, this value can't be negative, right? This integer variable attribute can't be negative, for example. But what we could do is through the set method. You remember the setters and getters? Through the set method, you could tell whether or not something could be a certain value or not, right? In our database utility, however, what we're going to be able to do is we're going to be able to say for a specific column, there's a set of allowable values. Like we can only have this particular column can only have values of a certain type, right? Can only have positive values, can only have values within a certain range. So for example, one thing that you'll see show up later in some of these slides will be you'll have like a sex or gender column for a person. Right, so the table represents a list of people. One of the columns will be gender or sex, and it'll say it has to be either M or F. Okay, so it's kind of saying you can only have certain values in here. Anything outside of that is not allowed. And we'll talk about what happens when someone tries to put a value like that into our database. Okay, a value that's outside of the allowable values. We'll talk about what happens with that. Okay, some more OR terminology. A tuple, we'll call that a row of a relation. I don't use tuple very often. I will use, there's a couple other terms we'll talk about, record, row. Those are terms that I use most often to represent what a row is. But a tuple is something you'll see in the literature, in the text. And so when you see tuple, just know that that means row. So degree is how many attributes, basically how large is it wide. So how many attributes are there in a table? Cardinality is the number of rows. Okay, so how many records, how many rows do we have? All right. Okay. And then basically a relational database is just a collection of relations that have distinct relation names. So it's all of our tables put together. Okay. So if we look at an example, all right. So here, let's see. Okay, so here we have, this is a relation or a table. Right? The degree would be 4 because there's 4 attributes. Okay. And then the cardinality would be 5 because there's 5 rows. All right. So each one of these is an attribute. So you could see how you might have like a branch. Might have a branch class that would have 4 variables inside of it if we were writing this in Java. All right. And then each of these rows would represent an instance of that class or what? Or an object, right? So each one of these would be an object. And in a lot of ways, this is like an array or an array list of those objects, right? Not completely. It's not, don't think of it as completely like an array or an array list, because there are some cool differences in how we'll be able to search through this that an array or an array list would not provide us. But in a way, this is like a grouping, which an array list is, but a grouping of all these different objects. So each one, so this branch, right, has this information in it. This branch has this information in it, and so forth. Okay. We'll talk about what a primary key and foreign key are in just a moment. Don't want to get there too soon. All right. Okay. So this is just some examples here. All right. Some attribute domains, for example, is you might have the character size can be 4. It must be a 4 character string or varchar or whatever, or text or whatever word you want to use there. All right. It's going to start with a B, and it's going to go from 1 to 999. So anything outside of this, anything that starts with C or a B000 would not be allowed. Okay. We would not be allowed to put that value into the branch number field. Okay. Some other examples here. So you have a date range, so it's a date type, and it must be from certain date up to another date. Oh, sorry, it must be from a certain date. Okay. All right. 20 would represent 1920. So basically what we're saying is anybody born before 1920, we assume they're probably not really working for us, right? Another possibility that you might put in here is a date of birth cannot be in the future. So we could not put a date of birth in that is, what's today, the 8th. So we couldn't put a birth date of the 9th of March, for example, in 2021. Right. So some other restrictions here. So domains restrict what values we can and can't put in there. All right. So again, just for a quick understanding of some of the terminology, relation is a table. We also sometimes call it a file. I can tell you, for me, I will use this alternative 1 I will use these three terms most often. Okay. I may sometimes use others, but most often I will use table, row, and column. Okay. But a tuple, as I said, is a row. It could also be called a record. An attribute is a column. It could also be called a field. Okay. All right. So these are just three terms for each of these situations is three terms that all mean the same thing. Okay. Now, I won't get too much into the mathematical definition because one, we don't really have a whole lot of time, and two, it can get a little bit complicated, especially if you don't have a strong math background. But basically, if we wanted to define a relation in terms of a mathematical terminology, this would be a set of example slides. If you really love mathematical terminology and proofs and stuff like that, these next couple of slides would be for you. And they're available on the class materials folder. So if you want to look them up and go do them and go check them out in your free time, you're free to do that. But we won't spend a lot of time here on that today. Okay. But basically the idea is that the set of all possible values is basically the Cartesian product of all the sets of all the different possible values of each domain. Okay. All right. So another word that you'll see show up is this schema word. Basically, it's just saying, okay, what is the named relation? We call that a relation schema. Okay. And then the relational database schema is what is the set of all the relation schemas? What is the set of all the tables that each have a distinct name that are in our database schema? Okay, so it's basically, so this is saying, this is like defining what the relation is. This is defining what relations are in our database. Okay. All right. Some important properties of our relations is that they will each have a distinct name from all the other relations that are in the schema. So we can't have two tables with the same name in the same database. Okay. So let's take the university database, for example. There won't be two student tables. There won't be two course tables. If we're going to have a second table, and we would like to have it have a similar name, we need to name it something distinct in something else so that we better understand what each of those tables is for. Like, why would we need a separate student table? Well, you might say, oh, well, we might have some students that are regular students and some students that are graduate students. And that's true that there are some differences there, but there's not enough differences between those two things, between those two items, to give us a reason to get another table out of it. We would just put grad students in with the student table. Okay. All right. Each cell, so each cross, the column row contains one value only. Okay. Now, that doesn't mean that the cell can't contain two things put together. So if, for example, we might have a database where there's a name column, and in that name for your row, we have your first name and last name together as one string or one piece of text. That's okay. So even though you might say, well, that's two values, it's not really two values because it's really first name space second name. But it's still one string. It's one piece of text. When we say we can only have one atomic value, one value, it's like one piece of text, one numeric value, something like that. So in other words, we could not put in the same cell your name and your age in the same cell, or your name and your birth date or something like that. Okay. So each attribute will have a distinct name. So just like when we create our classes in Java, right? Each property, each variable will have its own distinct name. Same thing here. We'll have a distinct name for our attributes. on our tables. Okay. All right, and values for an attribute come all from the same domain. This means they're all the same type. They're all the same. So like in an Excel spreadsheet, you might be able to have in the same column a mixture of different types, different data types. We won't be able to do that in a database. Okay. If a column contains numeric, it all has to be numeric. If a column contains text, it all has to be text. All right. All right. Okay. Each tuple is distinct. We'll get into what that means. There's a duplicate tuple. So each row, right? So each row is distinct, meaning that let's say we had 4 columns in our table. If I put in, so for the example that I gave at the very beginning of class, right, where we had Star Wars, George Lucas, I can't have another row with the same 4 values with Star Wars, 120, George, whatever, right? So I can't have another row with those exact same 4 values. And the reason why is because we're trying to, again, one of the things we're trying to do is we're trying to get away from data redundancy. We're trying to get to make sure that our data is consistent. And if we have a need for another row of the same values, why do we need another row that contains the same information? Right. Okay. The order of the attributes there's no problem. So we can change up the orders of the attributes. That's no problem. There's no meaning to putting order as far as the database itself is concerned. Now, for those of us who are users of a database, the order of attributes may be important to us, but in terms of the database itself, it doesn't store attributes that are closer to the front in the definition of the table. It doesn't store those in any different way than it stores the later attributes. Okay. And theoretically, the order of the tuples has no significance either, although searching can be helped if tuples are ordered in a certain way, but we don't have much control over that. Okay. All right. Again, kind of a bird's eye view on what some of the ideas of keys are. So the super key is any attribute or set of attributes that uniquely identifies a row. So you're going to hear me talk about this a lot, the super key, candidate key, and then on the next slide we'll see primary key. You're going to hear me talk about especially the primary key a lot, but the whole idea of the super key is, so we said on, let's see, the previous one, yep. Each tuple is distinct. There's no duplicate tuples, but there's sometimes that we want a certain column or set of columns that isn't the whole thing, that isn't the whole row. We want those to be distinct as well. We want those to be unique as well. So for example, many of you, there might be many of you that where you could say, oh, well, a super key would be my name and my birth date. Yeah, okay, possibly. Now, it is possible that someone else with your name was born on the same day as you. That's possible. But you might get to, okay, what about my name, my combination of my name, my birthday, my birthplace, and my parents' names. All right. Now we're getting a lot closer to something that is unique, right? Yeah, so you're getting the idea, Tarana. So what she's getting at is what we're going to get into, which is called the candidate key, and then later the primary key as well. And in the next slide, we'll talk about the primary key. Is something that's specific to, that we don't have to look at all of the values. We don't have to look at all of the attributes in a row in order to determine what the uniqueness is. That if we can get, ideally, if we could get one column, one attribute that uniquely identifies a row, that would be great. We don't want to have to look at all the columns. We would like to be able to look at one column and say that column, that one column identifies the row, identifies all the rest of the row. And what she's saying, what Sana is saying, is your student ID is that. All right. Now, before you had a student ID, or before you had a TJ Kimlik number, all right, or yeah, or for me, I have a different thing. I do have a unique number for the Turkish government here, but I also have one for my American citizenship as well that America uses. It's a different number, right? But before I had that, what uniquely identified me, right? Well, my name, no, because there could be somebody else with my name. I mean, you know, there was a student here. You guys may know him. Got a student named Jim Yilmaz, right? His name is not unique, is it? There's another Jim Yilmaz out there, isn't there? Right? And so, name alone, nope, doesn't uniquely identify me. All right. Name and birth date, maybe. Well, we're getting better. We're more getting closer to uniqueness, but there still is a possibility that someone could be born on the same day with the same name. Right? We can add a lot more pieces of information to try to get to a uniqueness, to try to get to something that says, okay, that is that person. But what most governments have done, right? What most governments and most, I would say in all that I've been a part of, universities and other institutions, is they say, let's create a number that we give to that person and that it becomes their unique identifier. Okay. So in the case of the government, you have a TJ Kimlik number. That is your unique identifier. For the university, you have a student number. That, as for the university system, is your unique identifier. What would be the unique identifier for this course? What do you think? Yeah, right. For this particular course, CSE 204. Now, when I say this course, when those of you who are saying CSE 204, right? Yes, that is the unique identifier for the database system administration course at Octonese University. Yes, but some of you have noted that but what about there was a CSE 204 in 2020 and there's now a CSE 204 in 2021 and those aren't technically the same course. Right, so if you say, okay, course code CSE 204 plus year 2021 gives you this course, right? Okay, so there, what we might have is we might have a super key, something that uniquely identifies the row, right? Something that uniquely identifies the row that is a set of attributes, two attributes, a course code and a year. Okay. Now a candidate key is a super key that there's no subset. So if we had columns A, B, C uniquely identify the row, but A and B alone uniquely identify the row, then ABC is considered a super key, but A and B would be a candidate key because A, B, and C has a subset that also uniquely identifies the row. Okay, I'll show you. So for example, if we said, okay, the columns are course code, year, and number of students, right? Well, the course code, year, and number of students, that uniquely identifies the row, but the course code and year alone do it as well, right? So the three columns together, not a candidate key because there is a subset that works. Okay. Now, what'll happen is sometimes we may end up with more than one candidate key. We may have more than one set of columns, set of attributes that uniquely identify each row, and none of them have a subset that uniquely identifies the row, right? So but we need to choose one, right? So that's where we get into the concept of the primary key. So if we have a candidate key that we select, then we are going to give it a special label, a special name called the primary key. If there is no candidate key that already exists, we can create our own primary key in order to make that happen. And that's what's gone on with your student number, with your TEJ Kimlik number, with my identity number. These things were, that person did not have a unique identifier that we wanted to use, so we created one for them. Okay, so they created a unique identifier, they gave it to you as a number, and now everywhere that you show up in the database of the university, that number shows up to represent you. Okay. We can also refer to things called an alternate key that are simply candidate keys that we did not select. So we just choose one. If we have multiple candidate keys, we just choose one and make it the primary key. It's like an election. A bunch of candidates, we vote, and we make one the primary key. All right. Now, a foreign key, we'll talk more in depth about this later, but I do want you to understand that if one table wants to say, hey, I want to access the information from the other table, but I don't want to I don't want to store all the information from the other table, then it'll just store the value of the primary key from another table, or a candidate key from another table. Okay, so an example of this would be, we might have one table that's like the course information table, and that tells me what the title of the course is. So CSE 204, the title is Database Systems Administration. You might have the title, you might have some other information like how many AKTC is it? Maybe what is it? A description of what the course is about, that kind of stuff. So that we might keep in a course information table. That's going to be something that it doesn't matter if it's 2020, 2021, 2022, that information is going to stay the same. Then we might have a course, an individual course table, right? Or a course table that says, okay, now I want to talk about the CSE 204 2021 course. We don't need to store the name of the course and the AKTC of the course and all that in that table, because all that is stored somewhere else. So we just have a primary key in the course information table. CSE is the course code, CSE 204. Then in a course individual table, we would have a foreign key, CSE 204, to the course information table, and then we would also have some additional information like the year and what students and some other information like that. Okay. Again, bird's eye view, I'm introducing these terms right now. We are going to get way more in depth into them in future weeks, but I do want to introduce those terms right now. Okay. All right, so null is a very hard concept for a lot of students, a lot of programmers, right? Null is not a blank string. Null for a numeric type is not 0. Null for a Boolean type is not false. Null just means we don't really know. It's a value that we currently don't know. All right, so it could be incomplete or exceptional data. All right, and the reason why I'm getting into this is because null does not equal anything. Right? It's not the same as 0 or spaces. It's not even technically the empty string. It's not a no character string. Right? And we'll get into in an example when we start talking about SQL about how we can't say does something equal null. So we can't look for rows where some attribute equals null, because nothing equals null. Not even null itself, and that's so But I do want you to understand the concept that null represents incomplete, unknown data. Okay. So it could be, for example, if you're signing up for a website and you want to get an account on, whatever, Hepsiburada or whatever, and they ask you for some information like what's your name, what's your email address, what's your birth date, what's your whatever, and there's something you don't want to put in, right? You don't want to put in your birth date. So you don't put that value in. You click, make my account. It makes your account, and for your birth date, it leaves it blank. Does that mean that you don't have a birth date, that you were never born? Well, of course not. You were born, you have a birth date. It's just that for the purposes of that system, they don't know what that value is. Okay. All right. Well, we're running up against the break time. So let's go ahead and take the break now. Even though I'm not done with this set of slides yet, I'd hope to be done with this set of slides before the break. But let's go ahead and take our break now, and we'll do 2:30. We'll do 2:30. There's a question about the group project. Yeah, let's. If you need to ask on the call, we can do that. Otherwise, if you want to just email me or message on here, we can respond. We can talk back and forth during the break. But I will go ahead and end the recording now.